Right, it is 10:05 right here at my own time, and I'm going to welcome everyone again to this session. It is Architecting in the Cloud, and we're going to be learning a lot of things today. I'm your host, my name is Eunice, and together we're going to be learning what exactly is cloud. What does architecture or anything means? I mean, I don't know, but we have an expert here that is going to take us through the rudiments of what cloud is and how architecture is done in the cloud. His name is Yinka Daramola. Get ready to be blown away by our legendary AWS expert, Yinka Daramola. It's not just a tech guru, no, no, no. I would say that is a magician when it comes to wealth of experience and boundless passion for all things AWS. And together, we're going to be learning so many things today. Please know that you are allowed to ask questions at any point in time. You can either raise your hands up and we'll definitely answer your question. But if you're the shy person, you do not want to talk, please you can use the chat box and all questions will be answered. Also remember that the WhatsApp group is open for all questions. If at any point in time you need to ask questions, we will take it in. You'll be seeing different polls at different points in time. Please take our time to throw in your vote so we'll know that we are really passing the message to you. It's about time to move this to Yinka Daramola. Hello, Yinka. How are you doing today? Hello, Yinka. Please confirm you can hear me.
Yes, hello. Sorry, can you hear me?
Yes, loud and clear.
Okay, thanks a lot. I should join in another minute.
All right.
I'm struggling with one of my devices. So.
Okay, so we just want to know what to expect today. I mean, I'm sure I'm not the only one eager. I mean, there are also about 18 people eager as well to know what we would expect today. I'm excited about this session. So
Well,
why are you trying to join?
I'm told it's the entry level knowledge in the cloud. So basically, we'll be looking at cloud fundamentals. We'll also see how these lead us to understanding architecting in the cloud. So I hope we don't have experts in the room. Even on that, if you're an expert in the room, you probably want to learn from first principle. So we have about 2 hours. Yeah, we should be able to do justice to the topic. Thank you.
All right, sounds amazing. I'm looking towards this and I'm fully pumped. If you don't have your jotter, your pen, please make sure you get that now. Settle down, put water by your side because it's about to be a long ride of learning. This session promises to be exciting, above all, informative and educating. And that's what we want you to learn from university. If you don't know about university, university is a tech recruitment platform that connects tech resources with tech recruiters. So if you're here, you're a tech resource, you can just jump on www.university.com, create an account, and be part of people who would be working in a renowned tech company. If you're a tech recruiter here looking for top and qualified tech resources, university is your go-to. Please head on to www.university.com and we'll take it up from there. Hi, Inka. Are you ready now?
Yeah, I'm just trying to share my screen now.
All right.
Yeah, please do confirm.
Yes, I can see your screen.
All right, so I think we can start. So basically, today we'll be looking at uh, maybe it is right to call it cloud fundamentals. So it was a bit of difficulty um, trying to, sorry. was a bit of difficulty trying to balance what would be the right topic, because maybe we do not know the audience, the class, what they know, what they don't know, and what their aspirations are, what their expectations are. So it was a bit of a difficulty. But I'll balance the two between novice and the experts in the room. Okay, or will I say the intermediate experts in the room. So if you find it too boring, because there are things you know, have patience. Okay, we might lead you to learning a new thing. Okay, and if you're a novice and it's getting too complex, please let us know. Well, what I'm trying to do is to balance things with the far experts and the novice. Okay, so today we'll be looking at the concept of VPC and elastic compute. This is general cloud, but we tend to speak the language of AWS. Okay, where necessary, I will speak the language of Azure. So I also want to balance the two between the two cloud providers, but we will tend and shift towards AWS language more. So VPC and elastic compute. Okay, so let's quickly take a look at a bit of the foundation of the cloud fundamentals, the foundation. What is the cloud? Okay, so again, it depends. I can explain this using what you know, especially if you are already an engineer, if you understand how systems work on premise. So basically, we're talking about what are the two options that you have, cloud or on-premise. So those are the two options. So if you're not in the cloud, you're probably doing on-premise, or otherwise you're in the cloud. Okay. So for today, because of the 2 hours we have, we picked two topics within cloud fundamentals or architecting in the cloud, basically, VPC and elastic compute. So that the class doesn't go too boring, at intervals, we will be taking some 5 minutes or 3 minutes break, as the case may be, if you find it too boring. But normally we do this when we are having a day-long training. But because it's 2 hours, I want to make it concentrated and impactful, okay? So, the tools for today: get your Wi-Fi ready, make sure it works, take a tea break, and get your laptop ready. And sometimes we may get you to open Excel, okay? And this is you, okay? Super you. So these are the tools for today. Nothing spectacular. We're not taking any lab, so it is fine. All right. So I think we should get started now. Like I said, please, if you find the concept a bit too fundamental for you, have patience. If you find it too complex for you, please let us know. I'm happy to go over it. So let's make the best of the 2 hours that we have. All right, so we will start. I will quickly spend time to discuss the cloud and on-prem. Okay, because it's one thing to understand what the cloud is, but if there was no cloud, what do we have? So that's what we call the on-premise data center. Okay, so and that will be taking us to the concept of elastic cloud. Okay, so all right, so let's get started. So there's something you need to know. You need to understand that what we call cloud doesn't mean anything is in the cloud. It does mean that somebody is managing your servers for you. So typically, when you deploy an application, let us understand exactly what happens. Maybe you're running your mobile app, or maybe you go on a website, or You've used mobile apps before, you've gone on a website before. Let's see what happens at the back end. Okay, what is it that we call the back end, the servers? How do they work? So this is typically your mobile app in your hand, and that is you. Okay, so your mobile app talks to the servers, isn't it? So it uses the internet. So this is the internet. Okay, and it lands somewhere. It lands on a server that we call the web server. Okay, and from the web server, typically, if it's a 3-tier application, your web server talks to another server called the application server. We'll call it app server. Yeah, and typically, like I said, it's a 3-tier application. Your app server talks to another server called the database server. This is a typical web application. So that's it. Take a look. This is typically what happens. So the question is, where are these servers? I can only answer that if you tell me if you run your servers on a physical on-premise data center, or if you run in the cloud. Now, if you look at what is drawn on the screen, I haven't indicated the network equipment tool. Okay. I haven't indicated the network equipment, but that is not. But that is okay. That is not the concept for now. 1 second, please. Okay, thank you very much. So this is it. So you will need to understand this page because it's very crucial and important to everything we're going to discuss. Now, in the world, all to necessarily address your because to the internet. Internet. So
Hello, Inka. We can't seem to hear you clearly. All right, let's just wait a bit, about 1 minute. Let him get to switch his network and join back. Meanwhile, please confirm that you could hear him. You could see his screen when it was on, and also was he audible enough? Please drop it in the chat box so that we can make adjustments where necessary. Okay, Hakim said yes.
Eunice?
Yes.
Sorry, can you hear me?
I can hear you now. Definitely clear. I can hear you.
Okay, it's my beautiful iPad device that went off, so it's coming back up. Yes.
Okay.
Sorry. All right, thank you.
All right, Timothy. All right, I can see your message. Grace, Lija. All right. So we'll be back in 1 minute to continue the beautiful session.
All right, thank you. I'm sure you can hear me back. Let me share my screen again. Okay, yes, so I'm back. I'm sorry for that. My iPad just went off. So like I was saying, if I was an hacker, okay, if I was an hacker, okay, a demon there, if I know the IP address of your web server, and I realize that you are putting your sensitive application in there, then I will have a free day. Okay, so typically your application runs on the app server, not on the web server. So the web server is exposed to the internet, the app server is not. Between your web server and the app server is a firewall. So there's a firewall here. Okay, so you need to know that. So let me make it red. There's a firewall. This is a firewall. So there's a firewall between your web server and your app server. And maybe typically there may be another firewall between your app server and your database server, just to secure your network. So these are firewalls. Okay, firewalls are network equipment. Okay. Okay, so that's how it is. Let me make it big. So you need to understand this is how applications are deployed on premise. So you have the app server, the web server, and the database server. And I mentioned your web server, you don't put your application on it, is to receive traffic from the internet. It receives the traffic from the internet, is the one that talks to your mobile app, your web app, is the one that talks to them, collects the traffic and route the traffic to the app server. The app server is where your application is. So when you deploy your application, you deploy it on the app server, not on the database server, not on the web server. But your database server is what runs your database, maybe Microsoft SQL, Oracle, whatever your database is. It sits on the database server. Your app server runs your application, and your web server receives traffic from the internet. So this is how applications are deployed on premise. Okay. If you have any question, you can put it in the chat room. Okay, and I'll be happy to respond to that. All right. So if you understand this, let's see what the problems are. Or let me just pause for a minute and allow you to dissect this information. Okay. And while you are reflecting on this information you have on the screen, we need to now start seeing how is this done in the cloud, and that's what we're going to be learning. Okay, and when we talk about elastic compute, what do we mean? I think we should start discussing, when we say elastic compute, what does it mean? So the cloud offers the concept of elastic compute. That's what the cloud offers. And the best way to understand that is to reflect on this architecture and ask yourself, what could go wrong? What could go wrong? So what could go wrong is simple. Now I'm going to repeat that same architecture. I'm going to repeat the same architecture, okay, but I'll make it smaller. So now we have our web server here. That's our web server. We have our application server here, and we have a database server, okay? Now we have a customer here that connects to this guy. Then your web server routes your traffic to the app server, and this routes it to the database server, okay? Please do feel free to ask any question, all right? Okay, so what is the problem then? Now, let me tell you what happens when engineers, when they provision the web server, the app server, and the database server. They will ask you, so that we don't experience any kind of issues, how much volume are you expecting? Are you going to have a lot of customers or few customers? And I can tell you one thing, every business person is optimistic. Then you say, oh no, we're expecting 1 million customers. What? Okay, so that when 1 million customers come, we don't experience a situation where the server is unable to power the traffic, is unable to accommodate or perform well under such a load. So what they do is that they will supersize your web server, your app server, and your database server. Okay, they will supersize it, and they may even load balance. So you need to understand the concept of load balancing. So they may say, well, because we're not sure how many transactions you're going to be getting, I mean, it may be huge, it may be big, then this architecture is not appropriate. Then they will give you what we call several web servers so that they can accommodate your traffic as they are coming. Okay, can you see that? So these are the web servers now. So they're saying, instead of you having one web server, let us have 3 web servers, so that when all the Peters and Paul and James and Aliu and when they start sending the transaction, when your customers get big, there is something that receives their traffic. That something is the load balancer. That is the load balancer. We call it load balancer. It's balancing the load among the web servers. Can you see that now? Web server. So this way, we will never have a situation where, customers are plenty, but the web server is unable to accommodate the traffic. So that's the concept of load balancer. And now we have a web service now. So when the first traffic comes, it will send it to server 1. When the next one comes, server 2. When the next one comes, server 3, by which time server 1 is now free to take traffic, then server 2, server 3. So this is how your load balancer works. So maybe I should color the load balancer. So that's the load balancer. Okay. So it is the load balancer's IP address that is now known to the public. These, your customers, are in the public space. Okay. Now, the same thing happens between your web servers who will be routing traffic to your app service. That is, app server is where your application runs. So again, if you have 3 web servers, you may even want to have 5 application servers, because you don't want your application to come down at all. Again, it means we're going to have another load balancer, so that when the traffic now sends in, they send it to a load balancer. The job of the load balancer is the decision to send to app server 1, 2, 3, 4, 5. Load balancers are experts. They are piece of networking equipment that are expert at distributing loads. So the second load balancer then distributes the load to the various app servers. So this way, we have what your design is said to be highly available design. So when you are asked to design a highly available network, this is what engineers do. Then they will beat their chests and say to you, bring on 1 million customers, and our system will respond properly, adequately, will perform well. Why? Because they have deployed highly available architecture. They have deployed enough web servers and enough application servers to make sure they are able to power your load. Okay, so this is what you do on-prem. Now, today is May what's today's date? May the 13th. And we have provisioned this powerful architecture for the business. Now, business is just starting today, May the 13th, right? So question then is this. May the 13th, this architecture is expensive. Having 3 web servers, having 5 application servers, because we want to prepare for the load that is coming. But I tell you, businesses are optimistic. 1 million customers are coming. In reality, these 1 million customers may not come in 2-3 years. Yeah, let's be optimistic. This customer will come in 2 years. 1 million customers, the business will grow to have 1 million customers in 2 years. All right. So let's say that is the reality. So I want to ask the class, what problem do you have if you're a business person? You've been told to put up this architecture. It's going to cost you, on the average, this architecture is going to cost you some $3 million because you're expecting 1 million customers in 2 years' time. Then you put up an architecture to get ready. The reason why you need to put up this architecture to get ready, who can tell me what problem do you think you have with this situation? If you are the businessman, you are the CEO, you've told us, I'm your architect. I've asked you, how many customers are you expecting? You told me 1 million customers. That's a lot. Okay. So for the architecture, for the system to be able to power your customers, then I deploy this architecture you can see on the screen. And it's going to cost you $3 million. Tell me. So how, I'm sure, yeah, you have a problem with this architecture. So this architecture is making you to make huge investment upfront. The customers are not here. You're going to start building your customer from 1 customer to 5 customers to 6 customers to 10 customers, right? But here we've got you to commit to a $3 million investment upfront. The reason is this. If you don't do this now and your customers come all of a sudden, it takes time to install the servers, to configure the servers. Your customers' transactions will start failing. You don't want that. You don't want a situation where the engineers tell you, oh, your customers is now 1 million customers. You need to give us some 3 months to order the servers, to buy the servers, to install the server. All your customers are gone. You don't want that. So you commit to $3 million investment. Okay. So this is the typical situation on-prem. Okay. So upfront cost is huge. It takes time to configure the servers. It takes time. It takes some 3 months or 4 months to configure because you need to order, you need to buy, you need to install, you need to configure. So it takes time. It's expensive. So if you have an idea and an idea that will make your customers come quicker, an idea that will make your customer happy, you cannot configure your server at the speed of your idea because it takes time to configure those. So what do? That is where the cloud comes in. The cloud solves this problem for you. Let's see the problem we've seen. So far, you've seen the problem of upfront spend of your $3 million. Okay, that is what we've seen. The second one is the speed at which the architecture can respond to your initiative, to your ideas, is completely slow and takes time. All right. So let's look at, that takes us to the concept of cloud. So cloud says, well, you don't need to manage your data center. Data center is where you configure all of this server. You don't need to manage your data center. I've got a huge data center and you can come and rent servers. That is the concept of cloud. So cloud means somebody manages those data centers. Rather than you invest in data center, I have huge data centers, just come and rent service. So you don't need to commit to upfront cost of $3 million. Okay, then I'll talk to you about the concept of elastic cloud. But now that is the concept of cloud. So if you tell me what is the major difference between cloud and on-prem? On-prem means you are responsible for the servers. Okay, you are responsible for the servers. Okay, but in the cloud, you are not. You don't own servers. Rather, you are a tenant on a server, on somebody else's server. Now, who are these somebody else's? The people who provide cloud infrastructure for you to be able to come and rent, they are called cloud infrastructure providers. Now, let's learn to know what are some of these cloud infrastructure providers. One is AWS. AWS stands for Amazon Web Services, owned by Amazon. So AWS is a cloud provider. There is Azure. Azure is a cloud provider. Then there is Google, called GCP. Google is a cloud provider. There are so many other cloud providers, but these are the three most the popular ones, the popular cloud providers. So if rather than deploy your infrastructure in an on-premise cloud this way, requiring you to prepare for 2 years volume today, you can approach either AWS, Azure, or GCP, and they have huge infrastructure that you can rent. So then you can deploy your application in their environment. So that is AWS, and that is Azure, and that is GCP. So you have the opportunity to select from all of these three, okay? So what then does it mean to be in the cloud? Now, let's quickly think about the infrastructure that you have in the cloud. So this is, again, I want to take you back to on-premise infrastructure. So on-premise infrastructure before the cloud came, this is the architecture that we have. We have load balancer, we have web servers, we have application servers, we have database servers. Whether you're in the cloud, whether you're on-premise, you must understand this concept. Why do we need load balancers? We need load balancers because we want to distribute the load across several servers. That's the concept of load balancer. Load balancer is not a concept for the cloud. It is a general concept. So before you even learn the cloud, or you learn on-premise, or you learn anything at all, you must understand the general concept of infrastructure deployment. Load balancer, web servers, application servers, and database servers. So you must know their functions. Load balancer, I'm repeating, distributes load across several servers. So you need to know why, whether you are on-prem or in the cloud, why you need to understand the concept of load balancers. So therefore, if your choice is go to the cloud, you need the cloud provider to give you these services. So whatever your choice is, whether you choose to go AWS, or you choose to go Azure, or you choose to go GCP, they must do work. They must provide the services you need. The promise of the cloud is you don't need to buy this equipment. I have the equipment. Now, that is correct. Then the next thing that you will be asking the cloud provider is, oh, do you have load balancers? And they say, yes, we do have. Do you have servers for me? And they say, yes, we do have. Then you ask them again, you are asking me not to invest upfront. What solution have you got for me not to invest upfront? What solutions have you got if my customer becomes 1 million all of a sudden? What solutions have you got if business goes bigger than I ever thought and my customer becomes 10 million customers overnight? What solutions have you got? So those are the reasons why you need to understand the concept of the cloud. You need to understand what services the cloud providers offer and how these services meet your need, meet your architecture need. So before you go to the cloud, you need to understand the architecture need. And that is the reason why I took my time to explain this to you. You are to become an architecture, a network engineer, a cloud engineer. First and foremost, you must be an architecture, you must understand architecture. So the basic fundamental architecture that you need to understand is this deployment architecture for a typical web application. So now I'm repeating, whether you are discussing cloud or you're discussing on-prem, you must understand this basic architecture. So let me pause. Are there questions in the room before we go into the technicality of the cloud? All right, I think I have Elijah saying, I feel it's ideal for him to define AWS. No. Benefits of AWS? No. So the approach, Elijah, the approach is people should understand first and foremost the basic architecture, which is what we have done. So when you understand basic architecture needs you to understand in a typical deployment, what are the components of a deployment architecture, which is what is on the screen. Whether you are dealing with cloud or you're dealing with on-premise, you need to understand this basic architecture. Yeah, thank you. So what's the difference between web servers and application servers? Thank you. Okay, let me explain again. Your web servers, now, your web servers do not run your application. So when you deploy your application in your app server. Okay, so your web server receives traffic from the internet. You can see your users are connected straight to your web server, even though your Java application, whether your Java application, your Python application, they run on the app server. So when you deploy your Java or Python applications on your app servers. Okay, so the difference is that your app server runs your workload, runs your application. Your web server does not. Okay, basic, fundamental, entry-level understanding. Your web server receives traffic from the internet and routes it to the app server. So, for example, now if you want to log in on your mobile app, once you put in your password and everything, it goes to the web server, encrypted, and the web server routes it to the app server. It is the app server that will now check whether you're a valid user. Then it would respond back to the web server for the web server to respond back to your phone. Then the phone says, sorry, wrong password. So the intelligence sits in the app server. Your web server is just to receive your traffic. So this is a typical on-premise architecture and deployment. Okay. So is it safe to say the web server handles the front end while the app server handles the back end? No. So your back end is your app server. Let's just put it that way. Your app server is your back end. So all your codes, whether it is your front end codes or the back end codes, they sit on the app server. So your web server is just to receive your traffic in a typical sense, so that you can avoid exposing the IP address of your app server to the internet. The IP address of your web server is exposed to the internet. Yeah. Okay, so why is web server so important? Why can't the application connect to the app server directly? It is insecure. So if, like I said, if I am this guy here, the what's it called? The hacker, and you deploy straight to your app server, it means your app server has to be, the IP address of your app server has to be, your web server could be something like, yes, that's correct. Fine. Thank you. So yeah, so this guy, if he has direct access to your app server, it means your app server is not totally secure. Yeah, thank you. So I have a lot of knowledgeable people in the class. So now, another thing is that your web server runs a web server application. So, and there are several options that you have, from Apache to Nginx, for all the examples that I have seen, to AIX. We don't want to go too technical, okay? This is a foundation class. So your web server runs the appropriate application, your app server runs the appropriate application, your database server runs the appropriate application. So there are appropriate applications for each of these tiers. So this is what we call tier 1. Your app server is tier 2 tier, and the 3rd tier is your database server. So it is clear now, your web server shields your app server. It protects your app server from being seen by external people, by people on the internet, your users, your hackers, the good people, the bad people. So that's why you need a web server. So I'm happy you guys understand this architecture now. So understanding this architecture is important to understanding the cloud. Whether you're dealing with the cloud or not, you must understand load balancers. Whether you're understanding the cloud, you're doing the cloud or not, you must understand 3-tier deployment. You must understand the various tiers of web server, the app server, and the database server. You must understand firewalls and their roles. You must understand load balancers. So I think we've done good justice to that. We can just move forward now, okay? All right. So does this mean First Bank mobile app doesn't use enough load balancer when its mobile application is slow? And beautiful question. Beautiful question. This does not apply just to First Bank. It applies to all the banks. And also, you will see what happened in February during cashless policy, and the volume of transaction became really huge, and a lot of banks had issues. And a few fintech companies were really rolling, transactions weren't failing. So I like that from Tunde Olariwaju. That's a very good question. It helps us to understand the benefit of the cloud better. So let's quickly move on then. Let's move on. Okay, so again, let me also mention something to you, something you need to understand. The benefit of the cloud. Then we now move on to architecting. Okay, let's quickly talk about some benefits of the cloud because of the issue that Tunde Olariwaju raised. He asked the question, does it mean First Bank doesn't have load balancers? Okay, First Bank has load balancers. Every bank has load balancers. Okay, so, but don't forget one thing. Somebody asks somebody, what volume are you expecting? Well, I'm expecting 1 million, 10 million customers. You have to plan. You have to say you're expecting 10 million customers. So let's go back here. Let's go back here to explain the question raised by Tunde. Now, let's assume a bank has this architecture: 3 web servers, 5 application servers. Do you know what happened in February? All the banks were expecting, say, 1 million customers. All of a sudden, it became 5 million customers overnight. That was what happened. Do you know what happened then? It means your load balancer does not have enough web servers and enough application server to distribute the load to. That was what happened. So then your follow-up question will be, okay, if that happened, why can't they just provision more app servers and more web servers so that at least it can carry the load? That is it. So we say on-premise cannot run at the speed of what? At the speed of thoughts, at the speed of your initiative, at the speed of your innovation. So you come up with an idea and servers need to increase. You need to wait some time. It takes time to configure these servers. So that was what happened. You will realize that at some point, the banks now were able to power your volume. Transactions were not as much filling as it used to, right? It was because they now had enough time of 1, 2, 3 weeks to provision more servers, by which time you as a customer today, you're already dissatisfied with the bank. You're already annoyed. So this is what happened on-prem, and that allows us to explain the concept of elastic compute. So I'm going to use that to explain the concept of elastic compute. Again, we're discussing general cloud concepts. We're not even talking about AWS. We're not talking about Azure. We're not talking about GCP. We're talking about cloud concept. So we've seen the on-premise concept, and it has led us to the question Tunde asked, and it's helping us to go straight into the concept of the cloud. And that the first thing about the cloud is elastic cloud. Okay, we talk about on-premise and elastic cloud. Let me tell you what you will do in the cloud. Today, the 13th of May, your business is just starting. When you go to the cloud, what you need to do is to provision only one web server and one application server, even though you're expecting your volume to go to 1 million. That is your expectation. Your expectation is can go to 1 million, but what if God smiles at you and your customers become 10 million customers? Who says it can't happen? So the concept of elastic cloud is that the cloud is so elastic that even though you provision one server, you can set it up that please expand based on my volume. So if you have only one customer, when you launch your mobile app,
When you launch your mobile app, you have only one customer who you are your first customer, which is you. So only one traffic, one server. Okay. Now, you now introduce your server to friends and family. So you now have a lot of customers. Again, one server may just be just enough. Now your friends and family, you now got funded. A beautiful investor came and said, I love your product. I'm putting some $2 million for marketing. You now begin to market on Big Brother Naija. All of a sudden, Big Brother Naija advertisement gave you 1 million customers. Do you know what happens to Elastic Cloud? You don't need to worry. The cloud will just automatically provision more servers for you. And of course, the load balancer is there as well. So the load balancer is not a concept for the cloud. It's a general architecture concept. There's nothing on-prem that you don't find on the cloud. It's a general architecture concept. So that is the load balancer there. So day one, you will provision just one server, right? And put the load balancer there. Ready. Load balancer is ready. So the day your transaction becomes so huge, the cloud will just expand. That is what is meant by elastic cloud. It is elastic. It expands and contracts. So you can see. So which means you will get the bill you will get depend on how many servers run your volume. So let's say on weekend or at night when people are sleeping, do you know what the cloud does? The cloud removes the server. Why? The cloud wants you. That is what is called, another concept in the cloud is called on-demand. On-demand billing. You see now the difference between cloud and on-prem. Yeah, it auto-scale. So that is it. That is it. So we say the cloud is elastic and it auto-scales. It scales based on what? Based on volume. So if you think you're going to have 1 million customers, it's okay. If you think you're going to have 10 million customers, it's okay. Whatever volume comes, the cloud auto scales. It's depending on the volume. So at night when people are sleeping, if you go to your cloud infrastructure, you just see that only one server is running. Why? Because people are sleeping, no volume. By the time they wake up at 8 a.m. and people are already doing transfers and paying bills and checking balances and making statements, running statements, your cloud will begin to expand. Okay, based on the volume, and the load balance is always there to distribute your load. So this is the concept of elastic cloud. Elastic cloud auto scales. So imagine if your banks were in the cloud, you will not experience what you experience. The cloud will have auto scaled. Okay, will have provided just the resources needed for the volume. If the volume comes down, the number of resources comes down. When the volume goes up, the number of resources goes up. That is what is called auto-scaling or elastic cloud, elastic compute. Okay, now on demand, that is the bill you get depends on your demand. Okay, so and the question I have in this from time to time is that this auto scale, does the cloud architect have to set it or trigger anything, or this is done automatically without any human prompt? Thank you very much. So I think there are answers in your question. The cloud architect has to set it up. That's all. Once you set it up once, it does not require any human intervention. So you will set it up once that, please, I want to auto scale. You tell the cloud, please auto scale for me. That's what you tell. The architect will say, cloud, please auto scale for me. All right. So once you set it up that, please auto scale for me, I don't need to worry anymore. I don't need a cloud engineer. I don't need a database engineer. I don't need infrastructure engineer. I don't need a network engineer. I need nobody. I only need a cloud. The cloud is automated to carry out my instruction. So that's how it works. So no human prompt. It is automatic, but you must have set it up. So it is automatic, but the architect must have set it up to auto scale. Okay. And all right. So any other question in the room? Okay, fantastic. If you can put up a poll, let me know how the class is doing. Let me know how the class is doing. Okay. All right. So now let's go to the next concept. We're going to go to the next concept. Again, we're not going to discuss any cloud provider. We're not discussing AWS or Azure at this point. We're still just generally understanding the basic fundamentals of architecture in the cloud. Very basic ones, okay? So another concept we're going to learn is what we call a cloud network. Again, you will see me making analogies to the physical that you can relate with and the cloud concept so that we can get understanding better. So let's understand some networking. Okay. Now, if you run your data center, if you have seen a typical data center, even if you haven't seen one before, you will expect your data center to have 4 walls. You will have your data center to have 4 walls. Now, in your data center, it's also possible to have compartments. Yeah, you have compartments. Maybe, that is, you enter here, but you have these compartments, you have these compartments, you have these compartments, you have these compartments. Now, in networking parlance, language, this is your network. That's the perimeter, but it is not physical. It is not the bricks and mortar that you see. So we always have a perimeter, which is your network. So the first thing I say is this: give me your perimeter. And we're going to learn all of this, don't worry. It's very interesting, okay? Yeah, that is your network. Now, within your overall network, which is the perimeter, you can have compartments inside your perimeter, compartments, okay? Which is like you are having a house, which is like a big hall. And inside your big hall, you want to have smaller rooms, okay? So the smaller rooms, the smaller compartment is what we call sub-network, okay? So what we call it subnet. Sub means divisions of the network. So you have the network, which is your overall perimeter, which encloses all your infrastructure. These are your various servers. You can have your various servers. You can have your various servers. You can have your various servers. Now, you have your various servers in your network. Now, within the various servers, you can choose to put them into compartmentalize or compartmentize your various servers. Can you see that? So 2 concepts you've learned here is your network and your subnet. Your network and your subnet. So that's what you've learned. Your network and your subnet. So when you discuss whether you are on-prem or you are in the cloud, okay, you must know the concept of networks and subnet. All right. So network comprises the web server, the app server, and database servers. Okay. So your web server, your database servers, and your web servers, app servers, and database servers, they are deployed in your network. Thank you very much, Tam. They are deployed in your network. So now I'm going back here. Look at this diagram. You can see you've deployed your web servers, you deployed your app servers, 3 web servers, 5 application servers. You typically would deploy them in your network. Can you see that? Your network is your perimeter. See it as your brick and mortar. In the physical, you see brick and mortar, but in the networking sense, it is, can you see that? You have to deploy in your network. Do you know what it means? There is no other server that can be in this network except your server. Okay, so that's it. So imagine you've deployed your servers in your network. So let's draw another network. This time around, now I'm giving you this network. Look at this. This is your network. So when I say this is your network, we're coming to understand exactly what it means. All right. Okay. So this is your network. Now, let's say, for example, you are deploying only one web server, one application server, and one database server. Can you see that? So you have deployed your servers in your network. This is your network. So this is the app server, the web server, the app server, and the database server. That's it. This is the simplest network you can have. But when your company gets bigger and bigger and bigger and bigger, especially for a company as big as a bank, it is not this simple, because your customers are getting bigger and bigger and bigger. There's so many of them out there that want to do transactions. So you may now have a lot of web servers. Can you see that? A lot of web servers, a lot of application servers to run this workload. Can you see that? So now, for your mobile app, your banking app, you may end up having close to 50, 60 servers running them. Yeah, they're that big. Then, to make administration easy, so that at least I can see where are my web servers, where are my app servers. Then you can now say, okay, I'm going to create subnets, that is subgroup. So you can create a subnet for your web server, a subnet for your app server, and your subnet for your application database server. So then it means in this architecture in my network, I have 3 subnets. This is the description that you're seeing on the screen. I have a network and I have 3 subnets. Can you understand that now? So before we go into some technicality, because you will soon you have to hold your paper and your pen to do some computation now as an architect. Okay. These are subnets. So this is subnet 1. This is subnet 2. This is subnet 3. You will choose how you want to, you will have to choose how you want to group in your network. So like the example you have on the screen, this architect has decided to group servers into subnet based on the role they perform. So this architect says, well, I will group my server based on the role they perform. So all web servers should be in one group, one subnet. All applications should be in one group, one subnet. And all my database servers should be in one group, one subnet. But you can choose to group your servers in a different way. You can say, well, I want my servers to be grouped by the application they support. Then you can say, well, in my network, in my overall network, I have a subnet for mobile app. I have a subnet for web app. I have a subnet for other applications. So you choose how you want to group your subnets. So, but we'll come to that. All right. So nobody decides for you. You have reasons why you want to group your servers into different groups, and you know exactly what criteria you're going to use to group them. Okay. So then let's quickly talk about some engineering. So it's getting deeper now. So now, if you are AWS, in our AWS, which is Amazon Web Services, our network is called VPC, Virtual Private Cloud. That is what we call our network. That's our network. Our network is called VPC, and each of the groupings is called subnet. So that's it. I just thought to quickly chip that in. I did mention at the beginning of the class that we'll try as much as possible to balance the language, but we may tend towards AWS more often than not. So we understand now, anytime we're talking about VPC, we say, oh, I have a VPC, and in my VPC, I have 2 subnets. What do you have in subnet 1, by the way? Oh, well, that's why I keep my web servers. What do you have in subnet 2, by the way? Oh, that's why I put all my application server and my database servers and my subnet 2. Why did you decide to do that anyway? Well, you know, because the web server here will be exposed to the internet. So this subnet is exposed to the internet. Okay. And I don't want to put my app servers where my application runs and my database server where my database is. I don't want to put them in the same subnet, knowing fully well that subnet 1 is exposed to the internet. I don't want to expose subnet 2 to the internet. Can you see? That's a beautiful reason why this architect has decided to share, to group his servers. He wants to group servers that have access to the internet in one subnet, servers that will never have access to the internet in another subnet, and all the servers that don't need to be on the internet to be seen on the internet. Their IP address must never be exposed. I will put them in subnet 2. So when your customers sign up on your mobile app, they are talking to your web server, and your web server is routing the transaction to the app server. So web server's IP is what is known to the highs of the internet. Okay, they don't see this, but they see this guy. So that's a very good reason why I want to share my screen. I mean, I want to share my subnet. Okay, so let's quickly go and do some engineering. It is time for some engineering. We've done a lot of storytelling. So before now, let's quickly check what we've learned. We've learned a few concepts, a few important fundamental concepts. We started by, let's recall what we've learned. We started by describing a typical deployment architecture. So we need to understand when we deploy as an architect, when we deploy applications, what is the basic architecture? Okay, so we understand that we have apps, web servers, because our customers, okay, whatever application you've given to your customer to use, the application on the mobile app or the web app must be talking to a server. Now, that server is your web server. Why? Because the IP address of this, whatever they are talking to, the IP address is known to the public. So therefore, we need to first put a server there that does not run your application, but the server will collect traffic and send it to the app server. It is that you installed your Java application or your Python application or your .NET application. Okay, so this is where your application runs. Therefore, this app server is not seen on the internet. So this is a typical deployment architecture, and it's very important. Okay, important for you to understand this because you will need this knowledge as an architect in the cloud. Okay, that's good. So we learned this. We also learned the concept of elastic compute. That is the capacity of the cloud to auto-scale. That is to increase the number of web servers automatically or increase the number of application servers automatically within seconds. If volume goes up, if more customers join and more resources are needed, it auto-scales. We call it auto-scaling, or that's auto-scaling. And that's what we mean by elastic compute. Elastic compute is the capacity of the cloud to increase capacity based on volume of your traffic. And it is a very important aspect of the cloud. Another thing we learned on-demand billing. Unlike if you are installing on-prem, you have to invest upfront. Volume that is coming in 3 years' time, you already invested now. You're wasting money. But if you're in the cloud, you don't need to invest upfront. You deliver small resources for today's volume. And as your volume grows, you see the resources growing with your volume. That is what is called on-demand billing. Okay, on-demand billing is a very great aspect of the cloud. Okay, so that's it. And we've seen the architecture. Then later on, I think we ended by discussing the concept of network and subnet. Your network is the overall network. It's like the perimeter. Then within the perimeter, you can begin to group your servers into subnet. And how you group your servers is up to you. It's up to you. It's just like a company. In some company, the CEO is there for everybody, which is like the network. Okay. In some companies, they group internally by functions. They say HR, admin, legal, okay, IT, and so on and so on, marketing. This is a type of grouping. Okay, this is the type of grouping. Well, in some company, they have the CEO, rather than have HR, admin, legal, and admin. No, they have product 1, product 2, product 3. So inside each of these products, you now have HR, admin, legal. Inside of each product, you have HR, admin, legal. So it's up to them how they want to organize the company. It's the same thing that happens when you are in the cloud. You have your network and you have the groupings of your application. The grouping, you know the criteria for grouping. So, and I gave you a simple example of a criteria. Typically, we put all servers that can be exposed to the internet in one subnet so that we know that if you put any server in that subnet, the IP address will be known to the public. You don't make that mistake. Okay, thank you very much. So let's discuss networking, network addressing. This is a beautiful concept. Please, you need to concentrate. Is the same grouping applicable to on-premise? Yes. We call it LAN, L-A-N. So we call it, the network is the LAN. Now the subnet, we call it subnet. It applies to on-premise as well. Thank you very much. So that's why, you know, I told you everything we're learning, whether it's on-prem or cloud, they have basic architecture knowledge that you must have before you even start talking cloud or talking on-prem. If you don't learn this basic architecture and you just jump to the cloud, you will be lost. Okay, so now I'm happy with that. So that's a good question, Tam. So let's talk about networking. Let me give an example. You're a rich guy, you own a street. You're a rich guy, you own a whole street. How do we describe the street you own? How do you describe the street? Who can help me? Let's say you own a street. Somebody says, oh, you're a rich guy. You own a street in Lagos. How do we describe the street you own? Okay, who can help me? Anybody? How do you describe the street you own? Anybody, if you can talk, or you probably type it in the chat room. How do you describe the street you own? Anybody can help? It's titled. Okay, it's titled. Correct. What else? Who else can help? How do we describe the street you own? For example, if you're telling me I own a street, what's the next question I'm going to ask you? Thank you, the landmark. Thank you. Your name, thank you. Fantastic. So I think I have enough. The name, thank you. You will say I own, what's a very beautiful street in Lagos? Let's say there's a street called William Street. I own William Street. Okay, I own William Street. Maybe from house number 3 to house number 24. This is a good way to describe what you own. There are so many buildings in Lagos, but this chap owns house number 3 to house number 24 on William Street. That is the same way the cloud works. Or please, not only the cloud, that is the way the internet works. There are so many houses in Lagos, but this chap owns William Street, house 3 to house 24. We have already created what? A perimeter for what he owns. Let's think about so many houses in Lagos. So many houses in Lagos. But this chap owns William Street, house 3 to house 24. So this is showing the so many houses in Lagos, but this chap owns this. So what he owns, we have created a perimeter around it, right? That is what he owns. What he owns is what we call his VPC or his network. Can you see that? Inside what he owns, let's say he owns so many houses that he has now chosen to group them into group. Maybe one group here, one group of houses there, one group of houses. That's what we now call subnet within the network. So let's quickly take the same concept to the cloud. There are so many servers in the cloud. So many servers in the cloud. There are so many servers on the internet, sorry. There are so many servers on the internet. Let me take you one bit backward. There are so many houses in Lagos. But don't forget that each house is labeled. Each house has an address. Okay, this one is number 2, James Street. This one is number 5, Emmanuel Street. This one is number 6, Mafoluko Street. So every house is labeled. Every house has an address. The same thing goes to, let's come to the several servers on the internet. Several servers on the internet, or several devices on the internet. Each device or each server has an address. The address of each server is called IP address. So every device, your laptop, your phone, they have an IP address, just like every house has an address. So this is the IP address. Is it clear? Good, good. So if every server has an IP address, just like every house. Sorry, let me have a drink. Okay, so there are 2 types of IP addresses. Let's say, for example, for houses, imagine there are 2 types of address your house can have. Of course, your house has about 2 types of addresses. There's something called physical address. Number 2, James Street. That's your physical address. There's another type of address called PO Box. Yeah, whichever way, I can reach your house through either your PO Box or your physical address. The same thing goes with every server or every device on the internet. There are 2 types of addresses, IP addressing. There is IP version 4 address, and there is IP version 6 address. Those are the 2 types of addresses that a device can have on the internet. But we're going to concentrate on IP version 4 address. And just mention what IP version 4 address can take care of millions of devices, but it is not enough. It's been used up. All the addresses in IPv4 have been used up. It is not enough. When the internet started, we thought it was big, but all the addresses there have been used up. So we have to come up with IP version 6. So you need to know that IP version 4 has been used up and IP version 6 is going to replace it. IP version 6 can take care of trillion of devices, so we can never ever exhaust it. Okay, IP version 4 has been used up. So we're going to learn about IP version 4. Okay, let's see a typical, we've seen a physical house address. It must have the house number, it must have the street name, it must have the city and the country. That is the structure of a house address. It must have the house number, it must have the street name, it must have the city, and it must have the country. The same thing goes with IP addressing. Okay, an IP address has 4 components. IP address has 4 components, and each component is 8 bits. So there are 2 ways to say it. So let's look at an IP address. An IP address, in the way you don't say it, has 8 bits. Let's talk about those 8 bits. So there is 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. That is part 1. Part A has these 8 bits. Part B, another 8 bits. That is part B. Part C, another 8 bits. 2, 3, 4, 5, 6, 7, 8. And part D, another 8 bits. So let me try to understand, prepare your mind. There is no way you can discuss networking or as an architect without understanding IP addressing. It is very, very fundamental to understanding architecting in the cloud. Very, very, very fundamental. If you miss it, you can never, ever be a good architect. You may never be able to provision in the cloud. So it has 4 parts, part A, B, C, D. So this is 8 bits. Okay, so 8 bits, all right, can give you up to from 1, okay, this is binary, this is in base 2. Okay, what you see on the screen is in base 2. Yeah, this is base 2. So this guy can be, if you want to put it in base 10, that is the number that you and I relate with on a daily basis. This can be up to 256. I think, yeah, 256, 256, 256. So therefore, a typical IP address would be maybe 132.36.54.39. This is a typical IP address. None of these, this is part A, this is part B, this is part C, this is part D. None of them can go beyond 256. So this is a typical, okay, there's a break in the communication. All right, Mary, are you back now? Okay, can you hear me now? Okay, so a typical IP address is what I just showed on the screen. A typical IP address could be 54.63.32.5. All right, so this is part A, this is part B, this is part C, this is part D. I'm sure all of you've come across an IP address, but you never know how it came by. This is how it came by. Okay, so there are 4 parts to IP addressing. Each part is 8 bits long in binary. So in decimal, each part is 256 long. Okay, and I said to you, this is IP version 4 IP addressing, and it is used up. That is the disadvantage. So we're reusing IP addresses because all the devices in the world, there are so many that they've used up all the IP addresses, all the IP version 4 addresses that there are. Okay, so now we understand this. Now, let me go back to all the servers on the internet. So each of these guys has an IP address. Unlike the example that I gave of a man that owns all these houses in a street. The same thing goes with your servers on the internet. There are millions of servers on the internet, but the one I circled in yellow are yours. So how do we create a network? How do we create a boundary around the servers that you own? How do we create this boundary? Since we know the IP address, we know the IP address of each of the servers. How do we create a boundary around it? Basically, I'm asking a question. How do we create your network? How do we name your network? So when you have a network, you name your network with an IP address. So this is very important. Please pay good attention. So if your IP address is 132.64.32, okay, if the IP address you have is 164.64.0.0, now the way we identify network is what we call slash. Can you see that? A number. There's a number that will be here. I'm going to explain. Now, So don't forget, this is 8 bits. This is 8 bits. This is 8 bits. Each of these is 8 bits long. And if you want to name all the houses in a street, the street belongs to you. There are 10 houses in the street. If you want to name all this, if you want to give me the addresses of all the houses in the street, they will have the same country. They will have the same city. They will have the same street name, but the house number will be different. Can you see that now? When you want to name a house on the street, there are 4 components. There is country, there is city, there is street, there is house number. Can you see that? So the country is the same. The city is the same for all the houses on that street. The street name is the same. The house number is different. So in IP version 4, let's say the country code is Nigeria 234. Let's say the city code is Lagos 01. Let's say the street code is 36, for example, street number 36. Then all the houses on that street, their IP address will be 234.01.36. The house number. The first house will be house number 1. The second house number will be house number 2, 234.01.36.2, 234.01.36.5. Can you see that? So for this type of IP addressing, then we say we are fixing the first 3 components of the IP address, right? Can you see? We are fixing these 3 components because they are the same for all the servers, for all the houses in this street. Then it means this is the IP address will be 234.01.36.0/24 because we have fixed 3 components and each component is 8 bits. We fix this 8, we fix this 8, we fix this 8. It means we have fixed 24. So let me take it again. The IP address for all the houses will be 234.1, 234 for Nigeria, 1 for Lagos, .36. 36 is the number assigned to your street, then /0-24. So this is your network address. Network address saying, in my network, this country is 234, the city is 1, Lagos, the street is 36, then the last one will represent the house numbers. So which means the first 24 bits, 888, that's 8 times 3 is 24, is frozen. So if you tell me any IP address that has 234.1.36, I don't care what the 4th component is. That server is in my network automatically. Okay, but sometimes it's not 24 where we freeze. We may freeze 8. So which means 234.0.0.0/8. Who can tell me what this address represents? 234.0.0.8. It means we have only frozen only 8. That is, this can be anything. What does this address represent? This is Nigerian address. This address represents Nigeria. So any server that starts with 234 is in Nigeria. Okay. Now let me take it further. If I give you an IP address, Lagos is 1, Abuja is 2, Port Harcourt is 3, Ibadan is 4. So if I give you an IP address that says 234.3.0.0, I am fixing 16. I'm fixing this guy and I'm fixing this guy. Fixing it means all the servers must have 234.3, but they can have any other thing. Okay, this represents, if this represents addresses of houses. Therefore, what does this address represent? Who can help me? You can type it in the network, in the chat room. What does this represent? What does this address represent? Anyone? Who can try? Thank you. It represents Nigeria PH. Thank you very much. It represents Nigeria PH. So if I give you an IP address as 234.3, okay, .54.36, what does this IP address represent? Who can tell me? Anyone? Who can tell me quickly? Okay, it represents server number 36 in Street 54, Port Harcourt, Nigeria. Can you see that? Server 36, Street 54, Port Harcourt, Nigeria. So this concept is exactly what network addressing represents. So if you understand this concept, then you have understood network addressing. So we now move away from using analogies. We need to move on to real network addressing. But before I go, just to test your knowledge again, what does this IP address represent? 234.4.3.55. Who can tell me based on our analogies? Okay, please, who gives the addresses? Is it the company or the network provider? I'll answer your question now. Thank you. That's a very good question. Quickly, who is going to help me? What server address is this? Who can describe this server? I mean, or this house. Who can describe this house? 234.4.3.55. Server 55 in City 3. Server number 55, Street 3, Nigeria, Ibadan. Thank you. That's correct. That is server 55 in Street 3, Nigeria, Ibadan, Nigeria. Thank you very much. So now, beautiful. So now let's quickly think about it. Someone asked, who gives this server IP? And that's a very good question. Whether it's on-prem or cloud, who gives this server IP? So let's quickly understand that. Quickly, I will try as much as possible to make it simple, right? Let's say your city, you have a company in Lagos. You have a company in Lagos, and so this is the country Nigeria. That is Nigeria. Don't forget, Nigeria has an internet backbone, a point through which internet enters Nigeria. And of course, Nigeria as a country, just like any country in the world, they manage what we call the internet service providers. They manage the ISPs. Yeah, I just want to simplify it, okay? Now, so that is ISP, ISP, ISP. Now, the ISP, and they are needed for you to access the internet. And for you to access the internet, you need an IP address. So this is your company, somewhere in Lagos. And for whatever reason, you have only one server. This server must have access to the internet. So you subscribe to an internet service provider, right? So now, I'm going to assume that, there are 4 components. Component A, B, C, D. Each component has 8 digits. So component 1, just to understand it, don't worry. I'll go into the technical details. I just want to use this small analogy so that you guys can relate with who provides, how do we generate IP addresses, okay? Component A has been given to Nigeria. It could be maybe 17. So 17 has been told, hey, Nigeria, you are 17 on the internet. I'm just giving an example. So with all the ISPs, they know that the IP address they can give out the first part of the IP address they will give out is 17. This one to 17. This one to 17. Can you see that? That's 17 dot, 17 dot, 17 dot. So Nigeria will now say, hey, I have 3 ISPs in the country. You got the guys that ensure that customers get IP addresses. They say, well, ISP number 1, the second part of your address is from 1 to 30. ISP number 2 is from 31 to 100. ISP number 3 is from 100 to 120. Can you see that? They've assigned. So let's say this is you. Who has that question? TAM. This is TAM Limited. That's a good company name. You can think about TAM Limited, okay? So TAM Limited went to ISP number 3. This is ISP number 3. And say, hey, guys, I need internet. Therefore, the IP address that TAM Limited will be given to will then be 17 dots. So the internet service provider 3 will now say, I have between 100 and 120. I'm giving you 123. I mean, sorry, between 100 and 120, yeah, right? You say, wait, TAM, I'm giving you number 115. So the IP address that ISP3 will give to TAM Limited will be 17.115.0.0/16. /16 means don't touch the first 8, which is this guy, the first 17. Don't touch the second one. You know, each of these is 8. That's why you have /16. You can't touch 17 because you are in Nigeria. You can't touch 115 because you are with ISP3 and ISP3 has given you 115. Don't touch it. Therefore, the IP address that you have is 17.115.0.0/16. So, which means TAM Limited, you can play around with this guy in your company the way you like. So 17 because it is in Nigeria. 115 because that is what the ISP that you went to, that's what they gave you. Then they will say 0/0-16. -16 means because each of these components is 8 bits. So -16 means we have frozen 16, which means we have frozen this, don't touch it. We have frozen this, don't touch it. But you can play with the other 8. So your server, if I were you, you will now call it 17.115.0.1. That is the IP address you assign to your server, which means what? Server number 1 in subnet number 0. Can you see that? Server number 1, server number 1. Okay, maybe or again, maybe you can say .1.1. So server number 1 in subnet 1 with ISP3 in Nigeria. That is how to describe your server. Server number 1 because you gave it 1. Okay, subnet 1 because you gave it subnet number 1. I will tell you the concept of this subnet. So, question then is, how many servers can TAM Limited have? TAM Limited has this network address because that is what has been given to him. How many servers does he have? Don't forget that he cannot touch 17, right? He cannot touch 17. He cannot touch 115. They are frozen. He can only touch the other 2 components, right? Therefore, how many servers? This is a network address. This address that they give to TAM means this is an address range. This is a range of address. It shows that TAM can provision 17.115.0.0 up to 17.115.256.256. Can you see that? So it's a range of address. This is a network address. The 117.115.0.0 is a network address because it is a range of address, which means any server you want to deploy can take IP address between 17.115.0.0 up until 17.115.256.256. Then there's a formula to now calculate how many servers TAM Limited can possibly have. I don't want to know if it's going to go too technical for the class. I can teach you how to determine the number of servers that TamTam Limited can have. So if you have exhausted the servers that you can have, you go back to the ISP. Give me another network. ISP will say, oh, you finished that? Okay, fine. I give you 17.118 because I have given out 116, I have given out 117, I have 118 left. So I give you 17.118.0.0-16. Then he begins to use that again. All right. So let me check with the class. Is this clear? I know IP addressing can be tricky. I was really worried if I wanted to teach you guys, but I said, well, I think the class is going well. That's why I decided to teach it. Okay, so let me see. Can you put up what's it called now? A poll. Can you put up a poll? Let's see how people are. If you understand it, if you think I should explain it again, can you put it in the chat room? Even for the very sound technical guys, it can be difficult to understand. But I hope you understand it. Let me see what you think. Should I repeat it, or you think it's good for you? You can put your comments in the chat room. I'm watching it. Quickly, please. I should repeat. Okay, thank you. All right. Okay, but do you understand how addresses are awarded? I think that's the starting point. Do you understand how IP addresses are awarded? Do you understand that? Yes or no, so that I know where to start from. Okay. Yes, you understand how IP addresses are awarded. Okay. I will just quickly do a recap of that then, even though you understand it. So just to simplify the understanding is the approach I've taken. Okay. So IP addresses are 4 components: component 1, dot component 2, dot component 3, dot component 4. Okay. So these are the 4 components. And that's why typically when you see an IP address, you see 54.32.63.39. This is a typical IP address. The first component is 54, the second component is 32, the third component is 63, the fourth component is 39. Yeah. So now, what does this mean? Like TamTam has, who determines this IP address? So there's a component that you determine. There's a component that somebody else determines. So I'm giving an example that on the internet, there's a body that coordinates how IP addresses are awarded. And I gave a simple example just for you to understand that maybe you're in Nigeria and the IP address that has been given to Nigeria, for example, is 17. So that is, which means all the servers in Nigeria, most likely, they will start with 17. So that's why it is easy for companies abroad who want to block you to know which country you are coming from. It's because they look at your IP address. Okay, so 17 has been awarded to Nigeria. So, which means all the servers in Nigeria will start with 17. Now, the next component, so this is the country, Nigeria. The next component, all right, the next component is going to be, because there are people in Nigeria too, that Nigeria, the companies in Nigeria, the ISPs, that Nigeria has given the authority to manage IP addresses. Let's say there are 3 service providers in Nigeria. Don't forget that each component can stand between 0 and 256. So basically, the first component, the second component, the third component, and the third component, it can start from 0 to 256. This guy too can start from 0 to 256. This guy can start from 0 to 256. This guy can start from 0 to 256. Or 255, I think. Okay? Yeah, so that's it. So out of 0 to 256, the world, the organization that coordinates in the world, I said Nigeria, yours is 17. The same thing with telephone. Remember, the organization that coordinates that in the world said Nigeria, yours is 234. The same way for IP address, they said to Nigeria, your IP address is 17. So Nigeria knows that any company, which means the IP address for Nigeria will be 17.0, 17.0.0/8. 8 means any server in Nigeria cannot touch the first 8. This is 8 bits. Okay, this is another 8 bits. Each of these A, B, C, D, they are 8 bits, 8 bits. So in IP address, that's why you see /8. /8 means for Nigerian servers, don't touch 17, don't touch it when you want to assign IP address to your server. So that in Nigeria, you cannot have an IP address that is 22.33.4.6. This is not a network in Nigeria because Nigeria is not 22, Nigeria is 17, okay? Okay, so this is just an example. Okay, so now, okay, so you understand that. Now 17 for Nigeria. Now, Nigeria Telecommunication Corporation too manages IP addresses in Nigeria. So there are, for example, there are 3 service providers: service provider 1, 2, and 3. Okay, so these service providers coordinate who have access to what. So Nigeria also says, hey, service number 1, we have, after the first component that you cannot touch, I give you the second component. But for the second component, which can be a number between 0 and 256, they say service 1, service provider 1, you have between 0 and 50. Service provider 2, you have between 51 and 100. And service number 3, you have between 101 and 150. So they've distributed the IP addresses across this service. And we haven't finished it. Don't forget that second component can stand between 0 and 256. So the world controls the first component. The country controls the second component. Nigeria controls the second component. UK controls the second component. US controls the second in their countries. So they determine how they award the IP addresses range to the ISPs. You understand that now? So, which means for ISP number 1, IP address can look like 17.0.0.0. 0 means, so it can be 0, it can be up to 50. So I'm now going to give you a small test. Based on what we've described so far, 17 is the first component for all servers in Nigeria. 0 to 50 is the second component is for service provider 1. 51 to 100 is for service provider number 2. 101 to 150 is service provider number 3. So I'm going to give the IP address of a server, and you're going to give me the description. So look at this IP address: 17.86.0.0. If this is for you, your company, and your company is TamTam, this is the IP address, the network address for TamTam Limited. What can you tell me about TamTam Limited? Guys, quickly, what can you tell me about TamTam Limited? Number 1, thank you. God bless you. TamTam Limited is in Nigeria, right? Is in Nigeria. TamTam Limited has subscribed to ISP number 286 because this second component, 86, the ISP determines what you get. So for it to be 86 is between 51 and 100. It means this this network address was given to TamTam Limited by ISP number 2. Thank you very much. I think you guys are getting it now. So guys, Busayo, you said I should repeat. Are you getting it now? So far, do you understand it now? Fantastic. Okay. So I want to go back a bit. I said to you that they've given Nigeria 17. So if I do, which means the IP, the network address, the perimeter for Nigeria is 17.0.0.0 slash. Who can tell me the slash? Is it /8 or /16? Quickly, who can tell me that? You get gold medals if you get it correctly. Is it /8 or /16? /8. Thank you, TamTam. /8. /8 means for all the servers in Nigeria, you cannot touch the first component, 8 bits. Thank you. Thank you. So, but for ISP number 2, who can tell me a possible network that ISP number 2 can give TamTam? Oh, sorry, ISP number 3. Who can tell me a possible network address that ISP number 3 can give to TamTam? Quickly, I expect it to be 17 dot what now? Anything? Quickly. From Grace, if that would, thank you. 111, thank you. .0.0, thank you. This is a typical IP. Thank you. 150, correct. 17.150.0.0/16. Thank you, Timothy. It's /16. Who can tell me why it's /16? Because if they give you this IP address range, you must not, when you want to assign it to your server, you can't touch 17, it has to be 17. You can't touch 111, it has to be 111, but you can play around with this. This is 8-bit, this is 8-bit. That's why you have to freeze 16. That is correct. Fantastic. You guys are getting it. Okay, so now you understand it. Now it means good. I'm going to start from where Timothy ended. Timothy said, TamTam Limited has been given this IP address range 17 for its company, 17.150.0.0/16. Timothy, what do you think is going to be the first? You cannot touch this. And you know that each of these guys can be from 0 to 256. From 0 to 256. Can you give me the IP address you're going to assign to the first server? This is now in your network. This is now in your control. You don't have control over 17, it is the country. You don't have control over this 150 because it's the ISP. But now you have control over this component and this component. Give me the address you're going to give to your first server. Now, this is your IP address that you can play with. You paid for this guy. So what's going to be the IP address? This first IP address, who's going to help me? The first IP address. It will be what? 17.150. Who is going to help? The first IP address for your first server. Who's going to help? Okay, 150.0.1. Okay. Well, thank you very much. Because it can start from 0. So let's assume it's 0.0. This is your first server. This is the real IP. Anything that has /16 is a range. Is a range of IP. But you can correct. So this is the first server that you're going to get. What's going to be the IP address of your last server for the last available IP? Who is going to help me? The last available IP in your network. What is going to be the IP? Thank you. 117.150. Thank you. You guys now understand it. Thank you. So from this first server to the last server, 17.150. Don't worry, this is just analogy. I know it's 255 you can get to. Don't worry, 256. So this is the first server. This is the last server. There, guys, is it possible to know the possible number of servers? There's a formula that can help you know the possible number of servers that this can give to you. Okay, so I think that brings us to the end of the class. Yeah, we're doing pretty much on time. I have a question. Okay. Oh, great. Okay, are there applications that change IP address to another country? And if yes, how is it done that it doesn't affect the one in that country? Okay. All right. So I know what you're talking. So I'm in Nigeria. My IP address will give me away that I'm in Nigeria, but I don't want them to know that I'm in Nigeria. Okay. And how is this done? How is this done? So okay, so let me explain how it is done. I hope it's not going to go too technical. Thank you. Yeah, VPN and remote desktop. I think it will be too technical for the class. Possibly I will discuss that in the next class. Because that will explain, I will need to explain how the internet works. Okay, so if this is your device, the traffic, when you open your web server. You have to install something on your device. Okay. I think I'll take that later. Okay. So you need to have a VPN client on your device, and your traffic from this is your PC. Traffic leaves your PC to your ISP, from ISP to an aggregator. Okay, so that would allow. I mean, I will need to explain how the internet works. Yeah, so it will be too complex for this class. I'll probably take that next class. Okay, all right. So can we take questions? So that we have about 20 minutes to just take questions. And is there any concept within IP networking and network addressing that you want me to take a look at? So when the next class will be to discuss subnets. Now that I've been given 17.150.0.0/16, okay, it shows I have about 16,000 servers that I can deploy. That is it. So am I going to group? If I'm going to group, what's going to be the IP address of each of the groups? Okay, so that will be the next class. We can't, if I start, I will not be able to finish it. That is, when you give this is your network. So when you go to the internet, the cloud, the first thing you deploy is your VPC. And to deploy your VPC, you will need a network address, which is what we now understand. Everybody understands that. But then if you now want, within the VPC, you now want to group your VPC into subnet. Okay, how do you play with your IP address range to give groups? Out of these 16,000, I want to group them into 4,000, 4,000, 4,000, 4,000. Okay, so each of these becomes a subnet within your network. Can you see the network? So we've seen the network IP address to be 17.150.0.0. So this is your network. So if the IP address given to you by the ISP is 17.150.0.0/16, this is your network address. This is like the street of Lagos that you own. This is like a group of servers that you own. That is your network address. Now, within the network address, you may now want to have 4 groupings, 4 subnets. Okay, that is your design. You want to have 4 subnets within the group. So each of these subnets will have its own IP address. So there is a way you need to understand how IP address will be assigned to each of these subnets, 1, 2, 3, 4, and which is something we'll take possibly in the next class if there's a next class. Yeah. So in summary, you've seen the power of networking. You've seen the power of understanding how networking is done, whether you are in the cloud or on-prem. So this general understanding, mistake people make is that you don't jump into the cloud and start learning the cloud. You must understand the fundamentals of networking. You must understand the fundamentals of architecture. Now, with these fundamentals that you've been equipped with, you understand networking, half of networking, you haven't fully finished it. You understand the half of basic networking skills that you need to have. You now have the deployment architecture skills that you need to have. Okay. You now know how IP addresses are assigned to servers. I mean, half of it, 50% of the skills you need to have. You now know those basic things. So if I give you AWS Cloud or Azure Cloud, chances are that you already understand how to find your way around it. The first thing, I need to create a network. What is my network address? After creating a network address, I need to move them into subnets, right? I need to deploy server into each of the subnets. How do I assign IP address to each of the servers in each of the subnets? Okay, it is coming together, right? That is the skill you need in architecting in the cloud. Okay, so the other side of architecture in the cloud that you need to understand is the one we started with, okay, which means we need to take it forward. We need to now discuss what are the various services, architecting services that the cloud offers. I'm going to spend the next 5 minutes while waiting for your question. What are the various services the cloud offers for us to achieve our networking goals, to achieve our architecting goals. Okay, so now the brief conversation we had around networking and the brief conversation that we have around deployment architecture has exposed the basic services that you expect the cloud to offer. Okay, so the cloud offers a wide range, over 200 services to achieve your architecting goal. There are compute services. Okay, there are compute services. There are database services. And the cloud gives you a lot of options. There are networking services. The cloud gives you a lot of options. There are security services. Okay, so I cannot put it on the screen. There are data and analytics services. There are machine learning and data science services. There are serverless services. So again, I need to teach you the concept of serverless. So the cloud is beautiful, it is big, and it is interesting. It is interesting if you understand things from first principle. Don't cram, don't force yourself to understand it. You must understand it naturally. If you understand it naturally, you want to live in the cloud the rest of your life. It's beautiful and it's interesting and it's quite rewarding because people get paid well for understanding what seems to me to be too basic. They get paid so much. Okay, so your compute services, basically you're talking about servers. For in AWS, we call it EC2. EC2 is like representing your server. It means Elastic Compute Cloud. In Azure call it virtual machine, VM, virtual machine. So they both represent the equivalent of your server. Okay, database options are plenty, from Dynamo, okay, to Dynamo is provided by AWS, the equivalent of Dynamo. Dynamo is not provided by Azure, but it has its equivalent. I can't remember now. So we have SQL Server in the cloud. You have Oracle in the cloud. You have all these servers are in the cloud. Options, you know, and networking. Of course, your VPC and your all in Azure we call it VNet. So they mean the same thing. They mean your network. And you saw the network. They offer IP version 4 address. You talk about your subnets and so on and so forth. Security, you talk about firewall. Basically, you talk about security group and all. So a lot of, but you understanding all these various services can only come if you understand basic architecture. And that's why I took my time to teach you basic architecture. Understand how things are configured naturally, irrespective of whether it is cloud or on-prem. So when you get to the cloud, you now ask yourself, which cloud service delivers this component that I want to put? Which cloud service delivers what I want to achieve? Which cloud service does this for me? So you now begin to configure those various cloud services. So there are so many concepts to understand. The concept of the auto-scaling, which we described. Serverless, you hear about serverless. How can I deploy without server? That's meaning of serverless. You understand the concept of serverless, and so on and so forth. All right. So then we can stop here for today and check if we have any questions. Let me check any question, and can you throw up a poll and see so that we know exactly if there's a concept that we need to quickly go over. Okay, by the way, do you understand networking now? Okay, can you throw out a poll? Let's see. And before I start asking my own question. Okay. So let's see if I can. I think the class says it's fine. No question. Okay. So let's get to understand some basic questions, some basic understanding of today's class, so that we can check if we understand it very well. Okay, so let me create more slides so that it can take as many questions as possible before we move on. Okay. Okay. I'm going to put two IP addresses on the screen. 17.32.50.60. This is the IP address of the server. And this is another IP address of another server, 17.32.38.31. No, sorry. The IP address of another server is 17.32.50.60. Okay, so someone told you, which one is that? Sorry, Tam. What concept is that? Can you put it? The one I just spoke about, which one is that? Do you mean this slide? This slide? Is it this slide? Okay, no, this is just telling you the various services offered in the cloud. These are various services offered in the cloud. Yeah, I will just stating the various services offered in the cloud. Yeah. Okay, so someone, an engineer of TamTam Limited. Okay, a networking engineer says, well, I have two servers. These are the IP addresses of this server. What do you think? Is this possible? If it is not possible, who can tell me why? Is this possible? Yes or no? Server 1 and server 2. No. Okay, why is it not possible? Okay, why is it not possible? Paul, why is it not possible? Thank you. So not two servers can have the same IP address. Thank you. Thank you. Fantastic. Okay, I'm going to change it a bit. Is this possible? Is this possible? Is this possible? No, thank you very much. So this is not possible. If TamTam is in Nigeria, then this is not possible. There is no way TamTam could have assigned an IP address of 38.32.50 to it, okay? But if these two servers are owned by different entities, let's say this guy is owned by TamTam in Nigeria, and maybe TamTam has a branch office in the UK, then this is TamTam in the UK. Then this is possible. Okay, fantastic. Okay, yeah. So let me also give you one more question, and this is I'm going to give you 17.32.56.0/24. Who gave this IP address range? Who gave this network? Is it Nigeria? Is it the ISP? Is it TamTam Limited? Who gave this network address? Is it Nigeria? Is it ISP or is it TamTam Limited? Okay, Timothy said TamTam, Akim said TamTam, okay, Paul said TamTam, Colin said TamTam, okay, Elijah said ISP. Let's see if Elijah is right. Tunde said Tam, correct. Elijah, you're wrong. Paul, Akim, Collins, Graves, Tunde, and Timothy, they're all right. Okay, so the ISP does not decide what this should be. The ISP only decides here. So the ISP should have given you 17.32.0.0/8/16. That's what the ISP will have given. Okay. So the ISP must have only given 17.32/.0.0/ what now? 16. But when he now got into so this is the network address for TamTam. This describes about 16,000 servers that TamTam can deploy, because TamTam can deploy between 17.32.0.0 up to 17.32.256, as the case may be, to 56. You get it? 255 actually. So sorry, it shouldn't have been 250, it's 255. So that's it. So what TamTam has done is that TamTam has now frozen 56. So TamTam has up to here from 0 to 256. So TamTam has frozen 56 and say any server I'm deploying can only have this change. All the servers in TamTam will have 17.32.56, 17.32.56, 17.32.56. All of them we have, because TamTam has frozen 24. He has frozen this, don't touch it. He has frozen this, don't touch it. He has frozen this, don't touch it. So let me now ask, if this is a network address at TamTam, 17.56, sorry, .32.56, sorry. So let's look at this guy, 17.32.56.0-24. If this is a subnet within TamTam, okay, what is the first in this subnet within TamTam? What will be the IP address of the first server? What will be the IP address of the first server? Guys, the first server, what will be the IP address? Who can help me? Fantastic, 0. Let's say it's 0. Okay, what will be the first IP address? Give me the full IP address of the first server in this subnet at TamTam. Who is going to help? The full IP address of the first server. Okay, who is going to help? The full IP address of the first server to be 17.32.56.0. IP address don't have hyphen. Thank you very much. 17.32.56.0. Thank you. Correct. What will be the IP address of the last server? The server with the last available IP. 17, thank you. 17.32.56.255. Thank you very much. So between here and here, you can only have 256 servers. If you count 0, 0, 1, 2, 3, 256 servers. So when you have 17.32.56.0/24, it means you can have only 256 servers. Okay. Fantastic. Fantastic. I think you're doing great. Yeah, you're doing great. Okay. I think we can just round up here. If there's any question, I'm open to answer your question, whatever it is, within the topics covered today. Let's take your questions. And I think you've answered my question pretty well, so everybody understands it. IP addressing is always a complex topic, but I'm happy that you guys understand it. So it's time for coffee.
All right, thank you so much, Yinka. That was an incredible session. If you want to have like a one-on-one session with Yinka, you can book him on TimeSlate. I will drop the link in the WhatsApp group so you can book a private session with him. Thank you so much, Yinka. We totally enjoyed that session, from deployment architecture to understanding IP addresses as well as on-demand billing. I want more, so I'm definitely going to book a session with you. All right, so this is University. It's a tech recruitment platform. We do this training every now and then, and we definitely do not want you to miss the opportunity. So we're going to drop a link to join our community because there's so much more packed for everyone here, and you wouldn't want to miss that. We also do a Tech Tuesday every Tuesday where we discuss industry topics regarding tech, any trends revolving tech, architecture, cloud, and you can also contribute as well. After this class, we'll be sending you the recordings of this session within 24 hours, as well as a poll, a survey poll, to get your feedback on your experiences during this session. Please note that we would not leave you. Our community is there and we would daily engage you. From me, it is going to be the end of the class, but don't forget, I will drop a link to book a session with Yinka Daramola. Thank you so much, and I wish you a lovely Saturday evening. Bye, everyone.
Thank you. Thank you for your time, and thanks for having me. Bye-bye.